Yeah, they sure are good, especially when you hadn't had anything. They're real good. All right, ultraviolet minus voodoo. Of course, we're just doing integration now. Now I can still throw some paint problems in here if you want me to.
No. If you talk about the luminous of uniform density,
What?
the luminous of uniform density.
What about it?
That one with that.
I don't think we did. I didn't know there was a question on there. I thought I went through it.
I had 3. They were like.
Okay, I'll adjust it. Don't worry. I'll look at it and see. I thought I had those off of there. I thought I just put Centroid. Huh?
I didn't have any Centroid.
That figures you probably got the ones with the, it probably regenerated with the other ones. I didn't know they were on there. Okay, I'll fix it. All right, whenever we have the antiderivative of u dv, that's going to look like ultraviolet minus voodoo. Ultraviolet minus voodoo. So you got to pick your U and your dB. You got to pick whichever one you want. I mean, pick it and then put it in this formula and then work it out. Sometimes you have to do it 2 or 3 times. Give you an example. Antiderivative of x e to the x dx. Okay? Now with derivatives, you would do first times derivative second plus second times derivative first. But you can't do that with integration. You have to do integration by parts. So in this case, you want to pick, dv to be e to the x because you can take the antiderivative of e to the x and it's e to the x. So here we're going to make dv equal e to the x dx. And u is going to be equal to x. Like so. Now, once you get u and dv, you just do the antiderivative and you do the derivative. The derivative of u is 1. And v is e to the x. And then you take this and plug into ultraviolet minus voodoo. So u is x, v is e to the x, minus the antiderivative of u, which is x. I'm sorry, v. Sorry. V is e to the x, and du is 1. And of course, the antiderivative of e to the x is x e to the x minus e to the x, and you can factor out e to the x, and you get e to the x, x minus 1. So that's an example, and we're going to do these till you're sick of them.
I'm already there.
No, sorry. You could have brought drinks,
I got mine right.
Okay, that's all that matters.
And water fountain out there for the rest of
I left my wallet outside.
it.
Really? I mean, really? Alright, next. How about you trying antiderivative of x squared, natural log of x, dx? Try that. You usually want to make your dv the easiest one to take the antiderivative of. How much is that one from? Anybody know it downstairs? Good God, I remember when they were 25 cents. I need 60 cents. I have to go downstairs and get it out of my truck. Alright. Ultraviolet minus voodoo. So I would make u equal natural log of x, and I would make dv equal to x squared dx. Now what's the derivative of the natural log of x? Huh? 1 over x. And the antiderivative of x squared is x to the third over 3. Ultraviolet, natural log of x, times v, x to the third over 3, minus the antiderivative, voodoo, x to the third over 3, du 1 over x dx. This is a whole lot better than paint, isn't it?
Yeah.
Yeah, just come on in whenever. That's fine. Yeah. X to the third over 3, natural log of x. Well, I'm going to pull the 1/3 out and go ahead and cancel that x. That'd be x squared. So minus 1/3, the antiderivative of x squared dx. And that's going to be x to the third over 3. Natural log of x minus 1/3, x to the third over 3, plus c. And final answer is x to the third over 3, natural log of x, minus what? X to the third over 9, plus c. You could factor out an x to the third over 3 if you wanted to. X to the third over 3. And that would give you what? Natural log of x. I don't know why this thing's not right good. Minus what? 1/3? Let's see. I didn't factor out. So all you have to remember is ultraviolet minus voodoo. Our machines don't take debit cards, do they?
I know the ones over at Pendleton, that's for sure.
We're gonna have to work on that. Do they?
I don't think they look like they ever take those. I've tried them.
Anderson campus sucks. I guess you have to trade off with not having to go with cardiac heal and have to put in parking.
That kills me.
Yep.
When you said that, or said that in the word.
All right, V is equal to what? 1. And du is equal to 1 over x. Ultraviolet minus 2. So natural log of x times 1, so that's natural log of x, minus the antiderivative of 1 dx natural log of x minus x. You good with that? Oh, wait a minute. Check my answer. Yeah, I did. Should be x, natural log of x minus x.
You put up 1 for
Yeah. There it is. There it is. So that should be dx, right? That should be x here. Then that would be x squared, wouldn't it?
There's no, I don't, there's an X there, but you have to multiply by 1 over it.
That's why I should have stick with my notes. Natural log of x times x. Natural log of x times x minus, okay, this would be x, 1 over x dx, right? Sorry, I was talking. X times 1 over x dx, and that's x over x, which comes out to be 1, which is x. Now let's try this. Oh, excuse me. I don't know why Bojangles put their Bojangles down here. I would have put Bojangles right here around this campus if I would. I mean, you have Lakeside, and then you have Tri-County Tech, and they put theirs down there at the bottom of the hill. Didn't understand that. V is equal to what? Negative cosine? Ultraviolet minus voodoo. U is x squared. V is negative cosine of x. Minus negative cosine of x du 2x dx. So we got to do it again. I pull that negative 2x out. I meant negative 2. I pull that out. Might help you out a little bit. Negative x squared cosine of x, and that negative 2x, or negative 2, will make that a positive 2 antiderivative cosine of x, and put x out front, dx. And let's see if we can copy that. Of course not. So U is equal to x. dv is equal to cosine of x dx. du is equal to dx. And v is equal to derivative, the antiderivative of the cosine is the what? Sine. X sine of x minus the antiderivative sine of x dx. Bring all this down. And what is the antiderivative of the sine of x? The cosine to make that positive. So your final answer should be negative x squared cosine of x plus 2 x sine of x plus cosine of x. squared, square sine of x plus 2 x sine of x plus cosine of x. I'm gonna let y'all do the next one on your own. See what you come up with. Better write small. Antiderivative of e to the x sine x dx. Got biscuits. Compliments of one of your fellow students, not me. Because I would have got McDonald's. Always make e to the x dv because that's easy to take the integral of. Kind of a hint. something, I get hiccups when I eat, when I don't have any. My mama has the same condition. She'll eat something and not have something to drink, she'll get the hiccups. That's why I haven't eaten my biscuit. Y'all finished yet? So I'd make dv equal to e to the x dx, and make u equal sine of x. I'm sorry, sine of x. Derivative of sine is the negative cosine. Just cosine. And d is equal to e to the x. So that's going to give us sine of x, e to the x, minus the antiderivative of e to the x, cosine x dx. Start it over. dv is equal to e to the x dx, and u is equal to cosine of x. D is equal to e to the x. The derivative of cosine is what? Negative sine. So that's going to be e to the x sine of x minus antiderivative of voodoo, which is e to the x, negative sine x dx. Which that negative can come out and make that a what? Positive. Now we do this again, but we're going to find out. We do it one more time, I believe. One more time. The e, let's see, dx or dv is equal to e to the x, and u is equal to the sine of x. D is equal to e to the x, and sine is cosine, right? Huh? I'm sorry, what?
That should be the one that you.
Yeah, that's what I was thinking. E to the sine of x. Yeah, we can bring that over. This can come over. I forgot to write the beginning of it. E antiderivative of e to the x sine of x dx is equal to e to the x sine of x plus antiderivative of e to the x sine of x dx. And this is the same as this, so what can we do? Should be a minus, shouldn't should it not?
Yeah.
Because the derivative of cosine is the negative sign, it should be a negative. Should it not? Cosine of x du e to the x.
It would be a minus, it would be negative, it would be like e to the x sine of x minus,
E to the x cosine of x.
and then that would carry over to the positive where it brings out like the.
I gotta do one more time. It looks like to me I gotta do one more.
So you can put in the UV for it. E to the x minus cosine of x.
Where? Right here?
No, what above it?
Right here?
Yeah. You got your UV minus.
Okay. Should be e to the x cosine of x.
E to the x sine of x minus e to the x cosine of x.
Sorry. I got mixed up. I should go by my notes. That way I won't mess it up. E to the x cosine of x. dv is e to the x. v is e to the x. dv is negative. I'm sorry. du is negative sine of x. That will give me e to the x sine of x minus cosine x e to the x, correct? Is that what y'all were telling me? Minus, what happens when you don't follow your notes? Minus cosine x e to the x minus antiderivative e to the x minus sine x dx. Just erase that bottom part so I don't get mixed up. There, that looks a little bit better. Of course, that negative can come out, and that'll make that a plus. And that would be just multiplication there. That looks a little bit better. So you should have e to the x sine of x minus cosine x e to the x. That minus comes out and makes that plus, but I don't see it coming out. I didn't take it out on here, but it should. I should have a minus right here. I distributed. I distributed negative right here. That's why. E to the x sine of x distribute to negative, and that's minus e to the x cosine of x minus the antiderivative of e to the x sine of x dx. That's where the negative comes from. And now you have this equaling this, so let's just rewrite it and then I'll take it over to the next page. E to the x sine of x dx is equal to e to the x sine of x minus e to the x cosine of x minus the antiderivative of e to the x sine of x dx. I know it's not going to copy of that. believe it. So I told you to write small? Okay, now you got this guy. You come over here, and one antiderivative of this plus one antiderivative of this is 2 antiderivative of e to the x sine of x dx is equal to e to the x sine of x minus e to the x cosine of x. And then divide by 2. And the antiderivative of e to the x sine of x dx is equal to, and you can make that 1/2 come out, and you can factor out an e to the x. So I'm going to do that. That'll be 1/2 e to the x of sine of x minus cosine of x. And that can be also written as e to the x over 2 sine of x minus cosine of x. And don't forget what? Let's see. That's a test question. I mean, to be able, it may not be that long, but to be able to see the algebra right here. And the algebra is combining what? Combining like terms. Alright. Let's look in your book. See if there's some in your book we can do. Huh? Yeah. Just go home, quit. Y'all are losers. Alright. Let's pull up your handy dandy book and see if we can find some in there to do. And then we'll move on. .1. I think that's the section we're on. Let's try number 9. Natural log of the cube root of x dx. Natural log of the cube root of x dx. you got the consumption again. Log cube root of x dx. Are all three of those the same thing? Yes or no? So all three of them can be used to get your answer. I think the easiest one is which one? I think this one's the easiest one. Pull that 1/3 out. I'm gonna go with this one. Pull the 1/3 out, and then you got natural log of x dx, and I think we did that one before, did we not? Where we made dv equal to dx, or d equal to dx, I'm sorry. And u equal to natural log of x du is equal to 1/x dx, and dv, or d, that's dv. Which one's dv? And v is equal to x. So now we ultraviolet minus voodoo. That'll be 1/3 natural log of x times x minus the antiderivative of x times 1/x dx. So 1/3 x natural log of x minus the x is canceled. What's the antiderivative of dx? Now you could factor out of x. Huh? Antiderivative 1 dx is x. Huh? Huh?
I just looked at
Yeah, the x is canceled. Factor out of x, and you should get natural log of x minus 1 plus either one of those equals. Now, another way you could have done it, you could have done the same way here. I think you see it would be a little bit more challenging. Let's get that way. Capiche? Let's pick another one. Just so y'all can feel confident with yourselves. Try number 12. P to the 5th, natural log of P dP. P to the fifth. P to the fifth, natural log of P dp. You know what's good on sausage biscuit? Mustard and grape jelly. It's the same thing you put in the weenies in the crock pot. Huh? You know the little weenies in the crock pot? Well, you don't, but other people do, and people eat them. It's real good. Okay, don't believe me. What are y'all talking about? Okay. I was fixing to say, I thought you got any jelly in there, dude. Oh well. Suicide, they used to call it escape plan. Let's see, P to the sixth over 6, natural log of P minus the antiderivative of P to the sixth over 6 times 1 over P dP. Do a little bit of cleaning up. Can't clean this up any. So P to the 6th over 6, natural log of P. That 1/6 can come out. And then you have the antiderivative of P to the what? P to the 5th dP. And I think we can do that. So that's P to the 6th over 6, natural log of P. Y'all have to excuse my writing down at the end. So 1 over 6, and that'd be P to the 6th over 6 plus C. So P to the 6th. Wish I could write that small. That'd be P to the 6th over 6, natural log of P, minus P to the 6th over 36 plus C, and we can factor out what? P to the 6th over 6, P to the 6th over 6, and that'll leave us with natural log of P minus 1 over 6 plus C. Just like playing the piano, you get better at it, the more you what? The more you want to quit. Exactly. Good job. I'm teaching y'all well. Hopefully by the time y'all get to Calc 3, y'all be done dropped out of school. Let's see. Let's challenge you a little bit. Let's go with, I'm not going to do 17 to you. I mean, you can if you want. Well, let's do 17. E to the 2 theta sine of 3 theta. E to the 2 theta sine of 3 theta. I should make these to where I can copy them. I don't want to have to copy them over. E to the 2 theta sine of 3 theta. Huh? Does it have one? Down here? Oh my gosh. I didn't know you could do that. Is it like a crop? Okay, what you? I can't believe that. Oh my gosh. I didn't know that. I didn't know you could do that. Thanks. Where'd you learn that? How did I copy it? Huh? This? It just copies it? Huh. Where'd you learn that? Y'all suck. Okay, why didn't it go? Oh, I bet I gotta insert it. No. Huh? That is so cool. Thank you. Blurry, but it'll work. Huh. Learn something new every day. Dang old student teacher. Dang old teacher. Alright. Finish it up. So I would make u equal to the sine of 3 theta so du is equal to 3 cosine of 3 theta d theta. dv is equal to e to the 2 theta, and that'd be 1/2 e to the 2 theta. Or e to the 2 theta over 2. So that's going to give you ultraviolet, which is 1/2 e to the 2 theta times the sine of 3 theta minus the antiderivative voodoo 1/2 e to the 2 theta 3 cosine 3 theta d theta. We'll have to clean up a little bit. So this can't be cleaned up, but this can. So 1/2 e to the 2 theta sine of 3 theta minus, we can pull out the 1/2 and the 3, right? Yes, Hubert. Thank you, class. Appreciate the interaction, boosters. Cosine 3 theta d theta. I think we're going to have about the same thing we had with that other problem we had. It looks like this is where it's going. Here I'm going to make u equal cosine of 3 theta. So that's going to be u equals cosine of 3 theta. So du would be what? Derivative of the sine is the what? Negative cosine? That's true. Negative sine. The negative sine would be 3 sine, negative 3 sine d theta. dv is equal to e to the 2 theta. So v is equal to 1/2 e to the 2 theta. So that's going to be 1/2 e to the 2 theta sine of 3 theta minus 3/2 brackets ultraviolet minus voodoo be 1/2 e to the 2 theta cosine of 3 theta. I don't forget what I just said. 1/2 e to the 2 theta cosine of 3 theta minus the antiderivative of voodoo, which is going to be 1/2 e to the 2 theta times negative 3 sine of 3 theta d theta. And I think that's where you're going to get right here. I think you're going to get that back with this. So if we can, let's we'll do it. I'm lucky today. And think once you clean this up, because that's still in brackets right here. I'm just thinking a couple of steps ahead. This negative 3/2 can come out right here, correct? And that'll make that a positive 3/2. Y'all help me out. Thanks for the help. E to the 2 theta, sine of 3 theta, minus 3/2, 1/2 e to the 2 theta, cosine of 3 theta, minus, be a plus 3/2 e to the 2 theta times the sine of 3 theta d theta. And let's pull in our heavy duty problem. Is that not what we got right here? Looks like it. But I need to distribute that 3/2, probably break that up. So let's distribute that, and we're going to get 1/2 e to the 2 theta sine of 3 theta minus what? 3/4 e to the 2 theta cosine 3 theta minus what? 9/4 antiderivative of e to the 2 theta sine of 3 theta d theta. And this is 4/4 over here, right? Bring over the 9/4 right? So that's going to be what? 13/4 antiderivative of e to the 2 theta sine of 3 theta d theta is equal to 1/2 e to the 2 theta sine of 3 theta minus 3/4 e to the 2 theta cosine of 3 theta and now divide by 13/4, which you divide by 13/4 on both sides, you multiply by what? 4/3, so that's going to multiply this by 4/3. I'm at 13, sorry, I just changed the problem. So let's do this. Yes.
Say you did all that down to where you have, like where you draw it on the picture, you can probably tell you equal 1/2 e to 2 theta minus 3/4 and minus the 9/4. What if somehow that, the way the function is worded, that can turn out to be a plus 9/4?
This?
Yeah. Would you subtract it to the other side and set everything to 0?
You take it over to the other side and it becomes
Well,
a negative.
If it wasn't 4 function matrix, like if they were the same function exactly.
Yeah.
It's different signs.
Yeah, you said it equal to 0, but You wouldn't get, the whole point of this problem is that this is going to be the same as this, so it's always going to come out like that.
So it doesn't matter whether it be negative on this.
No, because if it was negative on this side, this would make this positive and you'd come out with this. You're going to come out with this at the end of the problem no matter what. Because that's the way the problem is configured. This manipulation is all it is.
I just didn't know if the sign made any difference when you're moving it.
No, it's not going to come out and you're going to get, it's not going to come out where you're going to get something crazy. It's going to come out where you're going to get this guy right here by itself most of the time, or you're going to multiply 3 by this, which I think that's where I was, right? So the antiderivative of e to the 2 theta sine of 3 theta d theta is equal to, I have no idea, 2/13, help me out. Is it 2/13? E to the 2 theta sine of 3 theta. No. 2/13, and then I'm going to distribute it there also. So that would be 3/13, right? Minus 3/13 e to the 2 theta cosine of 3 theta plus c. And let me look at it one more time and see if there's anything you could factor out. You could factor out 2/13 e to the 2 theta if you wanted to. Let's see if they did it. Let me see what they got. What number was this? They got 1/13. They factored out 1/13 e to the 2 theta. I don't know why they factored out 1/13. Oh, to get 2 and 3. That's all. We got the right answer. It says 1/13 e to the 2 theta times 2 sine 3 theta minus 3 cosine 3 theta. Is that what? Yeah. So they just wanted a 2 and they wanted a 2 here and a 3 here, so they just factored out 1/13. All right, next section y'all have in this section, I think is just, hold on, trigonometric, yeah, that's what I thought it was. These are not that difficult. 7.2, trig integrals. And we'll start with something simple. Antiderivative sine 5th power of x cosine dx. Now what do you notice about this? If I set u equal to the sine of x, what's du? Huh? Du is equal to cosine dx, right? Cosine of x dx. So technically I have what? U to the 5th du, right? So antiderivative of u to the 5th du is what? U to the what? U to the 6th over 6 plus c. And what is u? U is the sine. So sine 6x over 6 plus c, or 1/6 sine 6x plus c. Now that's the simple one. You scale from 1 to 10, that's about a 1. Try another one. Now this one you're going to kind of cringe on. Pull up the old trig identities. Not the Pythagorean, because that would just cause a mess. Dang old double angle, dang old half angle. Alright, we'll pull them up on the screen. Because y'all done forgot them, right? Dang old trig identities. Can I blow it up? There we go. Just remember sine squared, take the square root of both sides. That'd just be 1 plus, yeah. That would work. 1 minus cosine theta over 2. 1 plus cosine theta over 2. That would work. Because you're squaring both sides. So you got to remember, you're squaring both sides. The sine squared identity here. This is the sine of theta over 2. We don't have theta over 2. What do we have? We have sine squared, right? So sine squared takes out the what? Takes out the radical, Hubert. So we got, for the sine squared of x, we have 1 minus cosine over 2. For cosine squared of theta, we have 1 plus cosine over 2. So those two are going to go in without the radical right here. So you've got the antiderivative of 1 minus cosine x over 2 times 1 plus cosine x over 2 dx. Now it's just a little bit of algebra. I'm sorry, what? Well, you want to change it because now you can factor out a 1/4. And you can factor out a 1/4, see what you get. And make it easier to work with. Dang old, then you have the shortcut. All the rest of it's algebra. Look here. watch this one step. Ready? And what do you got? Shortcut number 3. A plus b times a minus b, which is a squared minus what? B squared. This is nothing but manipulation. Here's the problem on the assembly line. Here's the problem with the machine. Here's the problem with the take it apart, put it back together. 1/4 antiderivative of 1 squared minus cosine squared x dx. And now what is this? Break these two up. 1 dx minus the antiderivative of cosine squared x dx. I'm sorry, that's cosine 2x. I'm sorry, I messed up. This is 2x. Minus identity. Cosine 2x squared 2x. And that would be total squared. I do have it squared, right? Yeah. And then you can change that cosine squared 2x into identity again and break it up. It'll be 1 plus cosine 4x over 2. Using the same identity. Take this over to the next board. I hate when I do that. As soon as I do one thing, it flips that little button and I hit the wrong button. I don't know why it does that. As soon as I go to the next, I can do it that way. Well, that's going to be 1/4 times the antiderivative of 1 dx minus the antiderivative, and you could rewrite this as the cosine of 2x squared dx if you want to. Because the square here gets rid of your radical, so you can rewrite it according to that identity. So that would go away, and that's going to be 4 theta. Well, the way this works out, since this is cosine, hold on, let me get out of this. Back here, cosine squared and sine squared by the half angle, come out with 2 theta, 2x over 2 right here, 2x over 2.
It wasn't under 3 definition.
It should do. Yeah, because it was divided by 2 right here. It would come out to be 2 theta. You're going to come out with 2 theta right here. and that would be 1/4. And we know that the antiderivative of dx is x minus, and that's going to give us 1 plus 4x, 1 plus cosine of 4x over 2. So that's going to be antiderivative of 1 plus cosine 4x over 2 dx. And now you're going to break that up because that 1/2 will come out. And then you'll be able to work with this. So that would be 1/4 antiderivative of x, or bracket x, minus 1/2 antiderivative of 1 dx plus, well, no, not 1 dx, but 1 plus cosine of 4x dx. And now you can break this up and get that cosine of 4x, which would be the antiderivative. Take it to the next page. Cosine of 4x, so you're going to need a 4 dx, so you're going to have to multiply by 1/4, and then the antiderivative of the cosine is the what? Sine? Yes, no, maybe. So that'd be 1/4 x minus 1/2, and then I'm going to put brackets here, and the antiderivative of 1 dx plus the antiderivative of the cosine of 4x dx. That'd be 1/4 x minus 1/2 bracket. Antiderivative of that's going to be x plus, and then cosine of 4x dx, we need a 4 here and a 1/4 here. And the derivative of the antiderivative of the cosine is the what? The sine, so that'd be 1/4 sine of 4x plus c. And then we can 1/4 here. Let's see, we've got to be careful here because we've got to distribute this. Let's see, this first. So that'd be 1/4 brackets x minus, that'd be 1/2 x plus 1/8 x, or 1/8 sine of 4x plus c. and then distribute the 1/4. That's going to be 1/4 x, 1/8 x, and 1/32 x. And that'll take care of the brackets. And you can factor out if you want to, but that's what I got. The 1/8 x and the 1/4 x you can combine, and 1/32 sine of 4x. Mine, I think I came out with, my final answer is 1/8 x. Would that be correct? What's 1/4? Change that to 2/8. Yeah. 1/8 x. 1/8 x plus 1/32 sine of 4x plus c. Change that to 2/8. And that'll give you a 1/8 x. And that's fine. Of course, we'll go over more of these when y'all come back, if we don't have another obliteration day on Tuesday and Thursday. I'll make up some homework for these two sections, 7.1 and a little bit of 7.2. Is everybody here today? Except for Mr. Fowler. I think everybody's here today. Y'all go ahead, I got you. Oh, somebody turn off my button, please.